Don't forget the Learn Smart. I know I've said this before, I'll just say it one last time, that the Learn Smart assignments are a required component of the course. There was some confusion, or small fraction of the class for some reason thought that those weren't required portions of the course. They are. I also got an email that asked me again about exactly how to calculate grades, so I'll go ahead and go over that again one more time. So I will take your midterm score and I will multiply it by 0.20, whatever that raw score is. Then I will take your second midterm score, I will multiply that times 0.20. Then I'll take your final exam score, I'll multiply that times 0.40. And then I'll take the average of your homework, I'll average all that together and I'll multiply that times 0.20, and I'll add it all together and I'll get a score. And then I will rank all of the scores in the class and determine a curve based on that final ranking. Okay? Make sense? All right, that's the way it's going to work. All right. So somebody sent me an email about that. Now I've told everyone, so we're done. We've gone over the grades. Okay. Questions about anything so far? Okay, so let's see if we can make some good progress through finishing up. We might be able to finish up this discussion with demand today. So let's see how we do. So we spent a lot of time in class last time talking about how we determine an individual's optimal consumption bundle, and I tried to give you some intuitive explanation for that condition. And let's just go ahead and start now talking about factors that might change an individual's choice of their optimal consumption bundle, or change an individual's optimal consumption bundle. So first of all, one of the things that can affect how much of a good we buy might be a change in our income. So let's suppose that this is our initial budget constraint. Recall that the y-intercept is m over p2, the x-intercept is m over p1. And let's suppose that our optimal consumption bundle occurs at point A. So again, this person has lots of indifference curves. I can go ahead and draw a couple more of them. This person has lots of indifference curves. All I'm drawing here is just the one indifference curve that corresponds to their optimal consumption bundle. And again, their optimal consumption bundle is going to occur at this tangency point between the budget constraint and the indifference curve. What's true at that tangency point? What's true is that the marginal rate of substitution is equal to the price ratio. There's another way of saying that the marginal utility of good 1 over the marginal utility of good 2 is equal to P1 over P2, which equivalently we can write as MU1 over P1 is equal to MU2 over P2. Okay, so all three of these equations say the exact same thing. And they all hold at point A. Okay, so at point A, the marginal rate of substitution is equal to the price ratio. That just means the slope of the indifference curve is equal to the slope of the budget constraint. Saying that the marginal rate of substitution is equal to the price ratio is the same as saying that the marginal utility of good 1 divided by the marginal utility of good 2 is equal to the price ratio, which is the same as saying that the marginal utility of good 1 divided by the price of good 1 is equal to the marginal utility of good 2 divided by the price of good 2. These are all equivalent. Okay. Now let's suppose that our income increases. So let's suppose that we get this boost to our income for whatever reason. So first of all, you have to think to yourself and remember, well, what does an increase in income look like? It's going to be a parallel shift out in the budget constraint. So m is going to increase. This y-intercept this x-intercept is going to increase. That y-intercept is going to increase, but there's going to be no change in the slope of the budget constraint. The slope of the budget constraint is just P1 over P2, which obviously isn't going to be affected by income. So let's suppose that our new budget constraint, and I'll try and draw a parallel line here. Let's suppose our new budget constraint looks like the following. Now I want to find a new optimal consumption bundle. So I want to find another point along this new budget constraint that is tangent to an indifference curve. And when you're drawing this, I think one of the things that gets tricky for students is that there's a lot of flexibility in terms of where you draw this new tangency point. Okay, there's not a lot of guidance without more information about exactly what these indifference curves look like. You have a lot of flexibility in terms of how you draw. But I'm just going to go ahead and pick a point and just imagine at point B, and we'll talk about my choice of this point in just a minute, but I'm just going to imagine that that new tangency occurs at point B, and to kind of show that it really is occurring at a point of tangency, I'm going to go ahead and draw the indifference curve that's tangent to point B. So, and this is fine. I've gone from one optimal consumption bundle to another optimal consumption bundle when we had this parallel shift out in the budget constraint indicating an increase in income. Now, I actually made an assumption in drawing this picture, which I didn't mention, so I'm going to mention that assumption now. Let's look at what happened to this person's consumption of good one. They went from, I'll call this x1 prime to x1 double prime. Their consumption of good one increased, and similarly, their consumption of good two increased from x2 prime to x2 double prime. Okay, so with this in mind, what's the assumption that I made in drawing this picture?
Both goods are normal.
That's right, both goods are normal goods. Okay, the way I drew my picture, and your picture may not look the same, okay? And, you know, I'll draw an example of an inferior good next, but because both x1 and x2 increased when income increased, this is a case where these two goods are normal goods. Okay, so in this case, both goods are normal goods. That was the implicit assumption. Okay, so now let's draw a case where one of the goods is an inferior good. So I'm going to go ahead and start off here with some initial budget constraint. N over P2 is the y-intercept, N over P1 is the x-intercept. And let's just suppose that this optimal consumption bundle occurs at point A. And I'm going to go ahead and draw a tangency between my budget constraint and an indifference curve right at point A. Now I'm going to make this assumption that good 1 is an inferior good. Okay, so what's possible? Someone give me the name of something they think might be an inferior good. Ramen noodles, okay? That's the one we've been talking about. Poor ramen noodles, okay? They're the fall 2013 example of a inferior good for econ 1, all right? Ramen noodles. So my income goes up. Again, that's just going to be a parallel shift out in my budget constraint. So now I have m prime over p2, m prime over p1. This parallel shift out. And now I want to assume that good 1 is an inferior good. So how do I draw this? Well, if I know that good 1 is an inferior good, I know that this tangency point, it's going to be somewhere along this new budget constraint, but the tangency point has to be somewhere to the left of point A, indicating that the consumption of good 1 is going to decrease when my income increases. Okay, so let's go ahead and just pick a point anywhere to the left of point A, call it point B, and I'll go ahead and draw an indifference curve that's tangent to point B. And now I can see, if I draw this, that my consumption of good 1, x1 prime, x1 double prime, my consumption of good 1 has gone down. And obviously my consumption of good 2 has gone up. So that's what an inferior good would look like. Now every year someone asks me, how do you draw this graph if you have two inferior goods? You can't do it. Okay, you can't do two inferior goods. It's not gonna work. Okay. But you could also think about drawing this graph for the case where good 2 is an inferior good and good 1 is a normal good. Okay, so that's something you can practice on your own. So in other words, just assume instead of good 2 being, instead of assuming that good 1 is a normal good, instead of assuming that good 1 is an inferior good, you can assume that good 2 is an inferior good and draw the picture that way as well. Okay, so questions about this so far? What happens when the income changes? Okay, so now let's look at price changes. Okay. So let's suppose that the price of good 1 decreases. So let's suppose that P1 drops. Right, the first thing we have to do is figure out how this budget constraint is going to shift. You can see from up here that the y-intercept is not going to change. You can see that if P1 falls, the x-intercept is going to move up, and obviously the slope of the budget constraint is going to decrease as well. Remember, the slope is P1 over P2, so if P1 is dropping, that slope is dropping as well. So the new budget constraint might look something like the following. The new x-intercept I'll call m over P1 prime. And again, there's a lot of flexibility. For students, I would say there's a frustrating amount of flexibility in terms of where that new optimal consumption bundle is going to occur. Okay? But I'm just going to draw it at point B here. There are lots of places that are going to work on this graph. Obviously, if you were to choose a point, and I'll just do this in red, if you were to choose this point like point C, that's not really going to make any sense given the way this first indifference curve is drawn. It's going to be hard to, you're going to have indifference curves that are going to cross if you try and draw a tangency point at point C. So probably not there, but really there's a lot of flexibility in terms of where this possible tangency could occur. I'm just picking a point, point B, kind of in the middle, because it's easier to draw, but there's no magic to it. Okay? What's really important is that wherever that new optimal consumption bundle occurs, it's going to have to occur at a tangency point. And so it looks like, the way I've drawn this, there's been an increase in my consumption of good 1. And we would hope that that would be the case, okay, because the price of good 1 fell. So actually, now sort of going back to this picture a little bit, thinking about this a little bit more carefully, we can put a tiny bit of structure on this problem. So generally, the law of demand tells us that when the price of a good falls, we tend to consume more of it. So it's likely going to be the case that wherever this tangency occurs, it's somewhere to the right of point A. Okay, because if it's to the left of point A, it's going to imply that as the price went down, my consumption went down. Right, so theoretically, it actually turns out to be theoretically possible for that to happen, but it's not what we usually think happens. Usually when we think of a price of a good falling, we think that our consumption of that good increases. So our consumption should occur somewhere, that new optimal consumption bundle should occur somewhere to the right of point A. Okay. So as you are thinking about this, so this is this movement from x to x1 prime to x1 double prime is just called the total effect of this price change. But I now want to talk about something called the income effect and the substitution effect. These are concepts that we've talked about before, but that actually become a little bit easier to understand once you see the budget constraint coming on, once you see the budget constraint up here. So there are really two things that are changing when you change the, when this price decreases. Okay, so this price decreases, I like to think of there being two things changing. The first thing that's changing is the slope of the budget constraint. Okay, so when we went from this initial budget constraint to this second budget constraint, the slope of the budget constraint changed. So one of the things that changed as a result of this price increase was that there was a change in the slope of the budget constraint. What does that imply? That implies that there's been a change in relative prices. Okay, so one of the things that's happened is there's been a change in relative prices. The other thing that's happened is that there's been an increase in the size of this person's affordable set. Okay, so initially when prices were relatively high, everything on or below this initial budget constraint described all the possible combinations that they could purchase. But now that the price of good one has decreased, this person can afford more overall. Okay, there are more combinations of good one and good two that they can afford. So there's also been a change in the size of the affordable set. And in some sense, this implies that purchasing power has changed. So both the change in relative prices and the change in people's purchasing power, you can think of those as having independent effects on people's consumption of good one. And that's what we mean when we talk about the income effect and the substitution effect. Okay, so I believe we've introduced these definitions before, but hopefully they're going to make a little bit more sense now that we've been drawing budget constraints for a week or so. So the substitution effect is the component of the total effect of a price change that results from the associated change in the relative attractiveness of other goods. Okay, so what do we mean here? This is the part of the price. So when the price of good one dropped, our consumption of good one changed. And part of that change in our consumption of good one was occurring because of the change in relative prices. So the example that we just gave, you guys the example from the previous slide. Good one became relatively cheaper. And typically when goods become relatively cheaper, we're going to want to purchase more of them. Okay, so there's going to be this change in relative prices that's going to lead us to consume more good one. But associated with this price decrease, there was also a change in our purchasing power. And the income effect captures the component of the total effect of the price change that results from the associated change in our purchasing power. Okay. And in particular, in that previous example, our purchasing power increased. And for most, and at least for normal goods, an increase in our purchasing power tends to imply that we're going to want to purchase more of the good. So what I really want you to sort of understand here is that when the price of a good changes, there's sort of two things that happen. One is that we're changing relative prices. We're making that good cheaper or more expensive relative to other goods, but we're also changing overall purchasing power. And both of those things have an effect on our consumption patterns. Both the change in relative prices and the change in our purchasing power. And this first one is called the substitution effect. The effect of the change in relative prices is called the substitution effect. The idea is that you're substituting out of one good and into another. The income effect captures the change in our purchasing power. So that the idea that our affordable set has changed because of these price changes, and that is also going to have an influence on the amount that we purchase. So hopefully, I mean, you guys, we talked about the income effect and substitution effect earlier on, right? Did we talk about that at all? A little bit? Did I introduce those terms? No one knows? Yes, I did. Okay, thank you for nodding. Do they make more sense now? Yes. Okay, good. All right. Hopefully they do. Okay. On your own, I won't do this today in class, but on your own, you can think about drawing a case where you have an increase in the price of good one. And I'm fairly certain that some of the discussion section questions will walk you through a similar example. So that's something you can try after class or this afternoon or whatever. What I want to move into now is talking about the effect of price changes on the demand for related goods. So far, we've mostly talked about, when I talked about a change in the price of good one, I really just focused on what happened to the demand for good one. Now I want to look at or think about what happens when the price of good one changes, what happens to our demand for good two. And I want to think about the case of complementary goods and substitute goods, and I want to relate this back to the shape of these indifference curves. Okay, so I'm going to move into talking about this, going back to complementary goods and substitute goods. Okay, so let's talk about what's going to happen with complementary goods. Let's again imagine, the idea now is that good one and good two are complementary goods. So they're butter and popcorn. Or actually, someone give me another example of two goods that are complementary.
Natty Ice.
What's that?
Natty Ice.
Natty Ice?
Is a beer.
It's a beer.
Yeah.
Okay, so beer.
And pretzel.
Okay, so beer. Let's just leave it with beer. I'm a boring middle-aged mother. Okay, so beer on one axis, and then what's going to be something you tend to eat with beer? Or drink?
Pretzels and
Pretzels. There we go. Pretzels. I know what pretzels are. My kids love those. Okay. All right. So pretzels and beer. Okay. So let's suppose the price of beer falls. One year in my cake evaluation, some student complained that I always did examples related to beer. And it's not my fault. It's just I'm just repeating what I do. Okay. Okay, so here's a decrease in the price of beer. So obviously, we have this drop in the price of beer, that the budget constraint shifts out in this way. Now let's suppose that these two goods are complementary goods. Okay, so first of all, now here's the problem. Here's where this gets tricky. You have to think about the answer to this question before you start drawing. Okay, so when you're doing questions like this on the discussion section questions or an exam, this is the point where you have to stop and think, and then you draw the picture after you do the thinking. So the first thing you think is, okay, the price of beer falls, so that probably is going to imply that my consumption of beer, and the quantity of beer is going to go up, right? Because if something gets cheaper, you're going to tend to want to have more of it. Now, if you're buying more beer, and beer and pretzels are complements, you're probably going to want more pretzels as well. That's sort of what we're saying when you have a complementary good. So you think that you're also going to be consuming more pretzels. So pretzels are also going to increase. Okay, so now that you've done your thinking, it wasn't a lot of thinking, but now that you've done your thinking, you can start thinking about where this new optimal consumption bundle is going to be. And it has to be somewhere that's going to indicate an increase in the consumption of both beer and pretzels. So you want to be somewhere to the right of point A, but also above point A. Okay, so you want to sort of be in this northeasterly, am I getting that right? Mm-hmm. No, yes, northeast, somewhere to the northeast of A. So point B is the candidate point. So I can draw another indifference curve that indicates that. And that's all I want you to do at this point. I mean, at this point, I just want you to sort of recognize that if these two goods are complements, we should observe an increase in both the consumption of good one and the consumption of good two when the price of good one falls. And one of the things that you'll notice is that because these goods are complementary, I've drawn indifference curves. They're not perfect complements, so they don't have L-shaped indifference curves. But I have drawn indifference curves that are kind of, I don't know how to describe them, they're sort of tight, right? They're sort of narrow. They're kind of approaching L-shaped indifference curves. They're not super wide. Okay, so perfect substitutes, you have straight line indifference curves. With perfect complements, you have these L-shaped indifference curves. Here I have indifference curves. They're not exactly L-shaped, but they're maybe in the neighborhood of L-shaped. Right. You'll see what I mean when we go to the next slide. So now I want to think about goods that are perfect substitutes. Or not perfect substitutes, sorry, that are just substitute goods. And you can see that the indifference curve I've drawn here between these two goods is much wider, right? It's closer to a straight line than the one on the previous slide, okay? Because these goods are more substitutable than the other one. Okay, now let's suppose that the price of this good over here falls. And actually, what are two goods that are substitute goods? Beer and wine. See, it's not my fault that I keep talking about beer and wine. Right? So beer, wine. Okay. So again, let's suppose that the price of beer falls. And let's go ahead and draw the corresponding change in the budget constraint. Now, if the price of beer falls, we're going to think that our quantity of beer is going to fall. But if these two goods are substitutes, if beer and wine are substitutes, then the quantity of wine demanded should actually increase. Sorry. You guys got to stop me when I'm being idiotic. Okay. If the price of beer falls, I will consume more beer, all right? Things get cheaper, you consume more of them. And if the price of beer falls, what am I going to be doing? I'm going to be substituting out of wine and into beer. So my consumption of wine should fall. Okay, so this is the thinking that you have to do before you start drawing the picture. Okay, so beer goes up, wine goes down. So now I want to find a point along my new budget constraint that's going to be consistent with an increase in my consumption of beer. So I want to be somewhere to the right of point A, but I also want to be below point A because my consumption of wine has to fall. So maybe a point right around in here is going to work. Right around in here. So I'll call that point B. And I'll go ahead and draw an indifference curve that's tangent to my new budget constraint at point B. And indeed, what I'm seeing here is an increase in my consumption of beer. And a decrease in my consumption of wine. Indicating that these two goods are substitute goods, because as my price of good one increased, my consumption of good two decreased. Sorry, did I say that wrong? My price of good one decreased, my consumption of good two decreased. Should I say it right? Now, why did it matter how I had drawn these indifference curves? You guys may be wondering why I was talking about the fact that for the perfect substitutes, I'd drawn these big, wide open indifference curves, and for complements, I'd drawn the tighter, the closer indifference curves. If in this example, I don't suggest that you draw this, but if in this example you had drawn really tight indifference curves, suppose that's the indifference curve you had drawn, it's going to be hard to find a point along this. If you had drawn this indifference curve that looked more like the case of perfect of complementary goods, right, with a tighter, sort of a tighter indifference curve. Do you know what I mean by a tighter indifference curve? It's got more curvature to it. It would have been hard to find a point. It would have been harder to find a point along this new indifference curve that represented a drop in consumption of good two. Okay, it's easier to find that point when you draw these big, wide open indifference curves that look like the indifference curves for substitute goods. Yeah.
So if it's not a perfect substitute or perfect complement, can you kind of use your own discretion and like how sure you want to be?
Well, I think if you think that two goods are substitutes, generally you're going to want to draw these wider open indifference curves. And if you think they're complementary, you want to draw them a little bit with a little more curvature to them. It's just going to be easier when you're drawing your picture. I mean, if you had drawn indifference curves like the one that I drew up here in red, it would have made it a lot harder to find the tangency point. There's some that are here, but your choices are kind of limited. So you can just use your judgment. If I don't tell you if goods are complements or substitutes, usually I'm going to ask you to make an assumption, and I'll state that assumption. But if I tell you, then you know. All right, so I'm going to get rid of the red line because it's confusing. Okay. Questions about this? Yeah. the independent effects, like the substitution effect and the income effect? So usually when you talk about the income effect and the substitution effect, usually you are talking about the price change. So I mean, I guess you could talk about the income effect of an income change, but typically when you talk about the income effect and the substitution effect, you're referring to the price change. Okay, other questions? Okay, so we're getting there, we're getting close. We have spent a lot of time talking about, so I told you guys what we're doing in this section of the course is we're kind of getting underneath the demand curve. We're getting underneath the market demand curve, and we're developing this model of individual decision making that's going to help us better understand the demand curve. And we've been working off of this graph where we have good one, some good on the x-axis, and another good on the y-axis. And the stuff we did on the earlier part of the quarter was that we had quantity down here on the x-axis and price up here on the y-axis. And what I want to do now is just show you guys the link between these two graphs. And it's actually pretty simple. Okay, so let's start off over here on the left with let's imagine that good one is pretty. Oops, I don't want red. Let's imagine the good one is pretty expensive. And I'm just gonna label what's going on the x-axis here, just to keep the graph kind of simple. I'm just gonna imagine that. Actually, I might as well label the y-intercept. There's no harm. And let's imagine that at this price, my optimal consumption bundle occurs right at point A. And that corresponds to x1 prime units of good one. Okay, so we've said this is a relatively high price, and we can see that we're consuming a relatively small quantity. So what I can think about doing, and I'm not assigning numbers to this, but I can go over to this picture on the right, and I can think, okay, we're at a point with a relatively high price and a relatively low quantity. And actually, just to be clear, let me just say that this is a lowercase a. All right, so lowercase a kind of corresponds to what was going on with uppercase a over there. All right, so at this relatively high price, we have this relatively small quantity. Now let's suppose that the price of good one falls by a little bit. I'm going to call that m over p1 double prime. So first, I'm going to go back and label this first intercept m over p1 prime. And that led to this optimal consumption bundle of x1 prime. And now we have this slightly lower price, p1 double prime. It's going to lead to this new x-intercept. And now we're going to have a new optimal consumption bundle. Maybe it occurs at point B, which I'll label here. And then I have the optimal consumption bundle at point B. And there I have a slightly higher consumption of good one. I'll call that x1 double prime. And now, over here on the right, I can go ahead and graph this new price, a new quantity level. I'll label that one lowercase b to kind of indicate that it corresponds to the point B that we had over there on the left. And we'll do one more of these. So now let's suppose that the price falls even farther to P1 triple prime. Okay, so now we've got this much lower price. Again, we can sort of find our new optimal consumption bundle. Maybe that's occurring at point C. correspond to x1 triple prime units of good one. So now I can plot that as well. And of course, what am I tracing out here? I'm tracing out a demand curve. It looks something like this. So now you can kind of see how we can go from this model of consumer choice to an individual's demand curve. So this is the demand curve for one single individual. It tells you at different prices what quantity of good wine do they consume. And it's going to come from, you can think of this as coming from this model of individual decision making, where individuals are choosing their quantities, their optimal consumption bundle based on their prices. And it's going to map over into this individual demand curve. Okay, so questions about this mapping so far? Yeah? Yeah, so if you want to use different notation, you're saying, go right ahead. I mean, in retrospect, it might have been cleaner if I had just done P1, P2, and P3 or something like that. So yeah, whatever you want to do. It's hard because we're keeping track of the price of multiple goods, and so I've been using the subscripts for the goods and the primes for kind of different levels. But however it's clear for you, go for it. Yeah. That's one thing, when you become an economist, you just become immune to incredibly complicated notation, right? There's just so much notation, you just get used to it. But I know that for people who aren't used to all these primes and marks, it can be a little bit overwhelming. Okay, other questions? Okay, so now we've got individual demand. Let's go ahead and draw market demand. Okay, because at the beginning part of the quarter, when we were drawing demand curves, we were typically drawing market demand curves. So how much of a quantity did the market demand? Well, now I want to think about a really simple case where there are only two people in the market, Al and Betty, okay, so whose names conveniently start with the letter A and the letter B. Okay, and let's go ahead and draw